Hello everyone. So this is chapter 11, but we will not be doing 11.1. We do not have that for this semester. So we will directly be moving on to section 11.2, contingency tables. Now, you would have heard about this in your labs, right? I guess it is lab 7, might be. Okay. So now, why do we use this contingency table and how can we make use of this? So when a data when write this in a new page. Okay. So this is chapter 11, section 11.1, test using contingency table. Okay. So when data can be tabulated, when data can be tabulated in a table form, we can do several tests. Okay, we can do several types of hypothesis test. So one among them is chi-square test. Okay. Now in this chi-square test, we have two types. That is test for independence, test for independence, and test for homogeneity of proportions. So so we do not have this one for our semester. So we will be concentrating only on this. Okay, test for independence. Now, what is this test for independence? Okay, so this is also called as chi-square independence test. Independence test. Okay, so this is used to test the independence of two variables. Okay, for example, um, let's say there is a new procedure administered by the hospital, okay, to the patients in a large hospital. Okay, now a researcher wants to know whether the doctors and both nurses are going to participate in this survey, and he wants to know how they feel about this new procedure. Are they okay about this, or do they prefer this, or do they do not prefer this, or they are okay with both? So he is going to do this survey, and here are the results. Okay, here are the results. Now there are two groups. He is just going to survey only for two groups, that is doctors and nurses. Okay, now how many prefer the new procedure? So let's make it a column: prefer, they prefer, or they do not prefer, or maybe both. Let's not worry about that here. Okay, I want to know whether they prefer or they do not prefer. Now according to the survey, here is the result: 180, 50 and 120. So 50 of the doctors, they prefer this new procedure, and 120 of them, they do not prefer. Whereas nurses, most of the nurses prefer this procedure, but only less people compared to that, do not prefer. So you can see that most of the doctors, they do not want this procedure, and most of the nurses, they want the procedure. So what can you see here is there are two variables. One is about the decision and another is the profession, right? So the decision depends also on the profession. Okay, so that's how we can write the null hypothesis in this way. The opinion or the decision, the opinion about the procedure is independent of the profession. That means the opinion doesn't depend on whether they are a doctor or a nurse. So that's what we are going to assume as null hypothesis, and your alternative hypothesis will be they do depend on the profession. The opinion about the procedure, the opinion is dependent on the profession. Okay. Now, let's say that we have performed the hypothesis testing, and let's say this is our initial conclusion. We are going to say fail to reject null hypothesis, fail to reject H naught. So what if I do this? What does that mean? That means that the new procedure or the test, hypothesis test, means that both professions will feel the same way about the procedure, and the differences are not so much. Okay, so meaning is that both professions both professions feel the same way, but we know that that's not the case, right? So let's say our initial conclusion is reject action. Okay, now I'm showing you both the cases so that you can understand well. So this might not be the exact solution for this answer, but I'm just giving you the possibilities. Okay, so now let's say the null hypothesis is rejected. That means the test, whichever you have done, that tells you one group will feel differently about the procedure from the other. So that's what happening here, right? So the one profession feels differently about the procedure. That means the opinion is depending on the profession. Okay, so this is how the contingency table. So now this is called as contingency table. So when you can write your data or your result in a tabulate form, you can call that table as contingency table. So when data are arranged in a table form for the chi-square distribution of your to perform a chi-square test, we call that table as contingency table. Now, as you can see, the table is made up of two rows, 1, 2, and two columns, 1, 2. Okay, it need not be only two, or I mean, just because I have two rows here, that doesn't mean I must have two columns. So it completely depends on the experiment you are doing. Okay, now next thing is about expected frequency. Now frequency is nothing but number of people present, or number of opinions, or number or we can say sample size in one word. And I have observed frequency. These two are quite important. Now, observed frequency, or let's say expected frequency, these are the counts which are calculated using probability. Using probability. Okay, and these are the counts made from experiment data. Experimental data. Okay, so let's say, for example, let us take example of a die. So let's say I am going to roll a die 10 times. Okay, now if I want to know how many times the let's say number 6 is repeating, then what do is you just experiment that first, and then you calculate the number of times it is repeating. Okay, now let's say another example, I'm going to roll a six-sided die. Okay, six-sided die. Now here I do not know the number of sides of a die. Okay, and that's why I'm not able, I will not be able to calculate the probability here. Okay, now here I'm going to roll a six-sided die. Okay, now if I want to calculate a probability of any number you want from 1 to 6, then your probability will be 1 over 6, right? So you do not have to wait until the experiment is completed. So once you know the number of side of a die, you can easily calculate the frequency. So that's your expected frequency. Okay, so this is example for expected frequency. That means you're going to calculate the count using probability. And if you're calculating a count after the experiment, that is called as observed frequency. So this is observed frequency. Okay, now let's get into the main section. Now I have gone through this. Now, objective is you're going to do a hypothesis test and to check whether the row variable and the column variable are independent or not. Okay, like an example of a nurse and a doctor. Now, contingency table, it's a two-way frequency table. We call that as two-way because it has rows and columns. R for rows, C as column. So it has 1 and 2. So it's a two-way frequency table, which mainly consist of frequency counts only. Okay, frequency counts of categorical data. This is quite important. Categorical data corresponding to two different variables. Okay, so that's called as contingency table. Test of independence, also called as chi-square test of independence. Here we do test for the null hypothesis and we check whether it is independent or not. Right? Now, these are the requirements the sample data which you got has to satisfy. First thing is it has to be randomly selected. That's one thing. And you must be able to represent the frequency count in a two-way table. Okay, that is second requirement. And third requirement, your expected frequency. Okay, observe here, we are talking only about expected frequency here, and it has to be at least 5. Okay, it has to be at least 5. That means it should be more than 5. Okay, but when you have a observed frequency, so most of the time what you get is the observed frequency and not the experimented frequency. Here, whichever frequency is mentioned here, these are the observed frequency. Why is that? Because a researcher has done the survey or the experiment and then he got the result, right? So if you're getting a count after the experiment, that is called as observed frequency. Got it? So your this requirement is not for observed frequency, it is only for expected frequency. Got it? And you will see how you can calculate the expected frequency using observed frequency. Now, these are the notations which we will be following in this section. Okay. Okay, so this is a procedure what we will be following while doing the hypothesis test. You all know that we have two types of hypothesis, null and alternative hypothesis. When you write H naught, that means the row and column variables are independent. When it is alternative, it is going to be dependent. Now, in this, it is always be a right tail test. Okay, this is always a right tail test. Keep that in mind. Now, you need to find a critical value and a test statistic so that you can compare critical value with test statistics here, and you can make the decision. That's also one way. And you can always compare p-value with alpha and make the decision. Okay. Now, to find the critical value, you cannot do this in a calculator like you did for chapter 10. Remember, you need to find degrees of freedom and you will have the alpha given. So while you were doing critical value for a correlation, you were considering sample size with alpha, right? Now here, when you're doing critical values, you will be considering degrees of freedom with alpha. Okay, I will show you how to find the critical value using the table. Now, when coming to test statistic, you can use the formula here, given here. It's quite simple, or you can do this in the calculator also. I will show you the steps on how to follow this. And again, p-value you can calculate using this, or once you do, while you are calculating the test statistic in your calculator, you will get the p-value automatically. Okay, so you can use that, or either way you can do this. Okay, now how can I make a conclusion? Now you're going to compare the observed value with the expected E value. Okay, if these two are close, then come here. If these two are close, then you have to get a small x square value, okay, and large p value. There is no notation defined for x square. We just call it as g square. Okay, so we call the x square as g square. Now, if you have a smaller x square and a larger p value, okay, you're going to fail. You're going to say fail to reject the null hypothesis. Okay, and if you have a larger x square and small p value, you are going to say reject null hypothesis or independence. Okay. Now, let's do a small example. Now, this is the contingency table. As you can see, you have rows and you have columns here. And what you can observe from this is number of rows and number of columns need not be equal. Okay. Okay, so we have alpha given as 0.05 and we need to test for independence using chi square. Now you're going to check whether the requirement is satisfied. And since it is randomly selected, it's a random sample. We can say the first requirement is satisfied. Second, you have a two-way table, number of rows and number of columns. So this is also check. And for every cell, the expected frequency is at least 5. So we do not know about this because we did not calculate the set. Okay. Now, there is no requirement that every observed frequency must be at least 5. So do not worry about number 3 here. So just because you have number 3 in the problem, that doesn't mean the requirements is not satisfied, because the value given here is for observed frequency. Okay. Now we need to know whether expected frequency is at least 5. So that's the main requirement. Okay, now how do you calculate expected frequency? Now to find the expected frequency, you have the formula row column multiplied with oops, row total multiplied with column total divided by the grand total. That means total of everything, all these two columns, rows, everything. Okay, now let us calculate the expected value for this one, for the first one. Now, if you want to calculate in that way, if I want to calculate the expected frequency of 54, what am I supposed to do? I'm supposed to do the row total. So remember, this is row. So this is row total. Row total. That means you are going to add the the numbers given in the row. So it is 54 plus 12. It is going to be 6. Okay, so 66 is my total. Column total, you are going to consider this column only because you are going to find expected value for 54, and that is why you have to consider only this column. So total of this column will be 182 and total of this column is 5, 6, and 8. 71. Okay, and the grand total is going to be adding by these two, that is 253. Okay, now let me write the row total here. So row total here is 54 plus 12. Just have to add all this. 54 plus 12, that is 66. 2, 9, and you have 73 here. 12. Okay, so remember, you're not going to add this and get to 53, but you just have to add these two and get to 53. All this is a row addition. Only this is a column addition. This one is a column addition. Okay, coming back here, we know that column total of this row, the first row is 182. So 182 divided by grand total. Grand total is 253. Okay? And this is for E54. E54. So when you calculate this, you have to get 47.478. So that's your expected value. Expected value is 47.47. Now you're going to do the same thing for each and every observed value, and I will give you the value here. If it is wrong, let me know. Okay. Okay. So now if you observe the expected values, you can easily say it is greater than 5, right? So you will do this only to check whether your expected values are more than 5, because it has to satisfy this requirement. If not, you cannot um, move or proceed further. Okay, so since all the requirements are satisfied, we will do the hypothesis test. So step 1, you're going to write H0 and H1. So this success is independent of the treatment. and failure, success, and the treatment are not independent. That means they are dependent on each other. That's your alternative. Now remember, always it'll be a right tail test. Okay. Now to find critical value, all you need is alpha 0.05 and degree of freedom. So degree of freedom formula is row minus 1. R means row and column minus 1. C means column. Now come back here. How to find the row value? You have 1, 2, 3, and 4. So R equal to 4. Okay, here you have column 1, column 2. So your column equal to 2. Okay, row is 4, column is 2 minus 1. The answer is 3. Now you have to go to your formulas and tables. Formulas and tables, and this is A6, and we need to find in table these are the score, the distribution, critical T value, and yes, you have chi-square distribution here. So you have to check in table A4. Okay, so our degree of freedom was what? Okay, our degree of freedom is 3 and alpha is 0.05. Keep that in mind and go back here. Alpha is 0.05, it's here. Okay, alpha is 0.05 and degree of freedom is 3. 1, 2, 3, 3. Come here. So I'll just make a straight line here and I will make a straight line here. Check whether at what point it is coinciding, that means intersecting. So it is intersecting at this point and this point is 7.815. Okay, 0.05 with degree of freedom as 3, you get critical value as 7.814. So your critical value of chi-square with df equal to 3 is 7.815. Okay. Now, how do you find your test statistic? Test statistic x square. Now you can use the formula given, or you can also do that using calculator. Let me do this using the formula first. So you have to, so this is how it works. Now, you know the observed value, you know the expected value, right? So 54 minus 47.478. Now, you're going to do this for every observed value, okay? Divided by 47.478 plus. Again, for the second row and third column, for the second row and first column, and it goes on. Okay, so this total will be 58.393. Now, this might be confusing part. You have to calculate for each and every value here. Okay, each and every value. So that will take a long time. Now, if you want to do that in a calculator, so what you do is new calculator, and I need a column. So go here and go to matrix. So to do this in the calculator, you will click on second matrix or matrix, which is x inverse here. So click on this and you will go to test, you will go to number 1. Okay, so you have to go to edit first, that is just click on your right arrow and choose number 1, that is E1. Okay, now what you can see here is 1 cross 1, that is number of rows and number of columns. So our number of rows is how much? 4, right? So always you will write number of rows first and number of columns as the second. Okay, number of rows is 4. Enter, and I will go to 1 here, and number of columns is 2, so click on 2 and enter. So now you can see you have 4 rows and 2 columns. You have to enter the values here. Okay, you have to enter the observed frequency, that's the original table, not the one which we have calculated here, not this, but you have to do this one. Okay, this one goes to the calculator. Okay, let me enter the values. 54, and next we have 12, 41, 51, 70, 3, 17, and 5. 17. This is okay. So once you enter all the data values in a table, go to stat and go to test. Okay, so here you will be choosing x square test, that is in option C. Let's go there, option C, this one, x square test. Okay, option C and enter. Okay, so your observed value is E. Okay, your observed value is E. Come down and just click on calculate. So this will give you both your test statistic value and the p-value. Okay, so let me go here and just write the. So your test statistic value of x square was 58.39. Okay, and your p-value is going to be, so you also have p-value here in the calculator, right? So that is 1.29. Do not forget about 10 power minus 12, that's important. 1.2957 into 10 power minus 12. Okay, so this is how you make the conclusion. Now since p-value, so we know p-value is nearly to 0, so p-value is less than alpha, right? So your initial conclusion will be reject null hypothesis. So what can you say about this? That means the success is dependent on the treatment. It's your final conclusion. Okay, and we will also do example 2. So alpha is given. You can pause the video and you can just repeat the procedure which I taught you in example 1. Okay, and you can see whether you got the same value or not. Now H naught is home or visitor. This is about the sports, home team and visitor team. So visitor wins are independent of the sports. Alternative, home or visitor. Dependent of the sport. Okay, now step 2 is this was step 1, writing the null and alternative hypothesis. Step 2 will be finding the critical value. We know that alpha is 0.05 and degree of freedom is row minus 1, column minus 1. Number of rows is 2, 2 minus 1, and number of column is 1, 2, 3, 4. So 4 minus 1, that is going to give you 3. So since you have the same thing, so df equal to 3, you will go back to the table and search for 0.05 and degree of freedom as 3. That is going to give you 7.815. Now I'm going to enter, I'm going to calculate the test statistic value. So let me clear this. Now go to second, matrix, edit. First one, I'm just going to clear this. You have 2 rows and 4 columns, enter. Okay, so first value is 127, 53, 50, and you have 57. Next is 71, 47, 43, 42. Okay, 43. Okay. Now again go to stat and test, scroll down, option C, X square test, enter. So this is your observed data which you entered as matrix A. Now matrix B is your expected value. You do not have to enter that. The calculator would have already calculated the expected value. Okay. So do not change anything and come here and enter the calculator. So your test statistic X square value or chi square value is step 3, test statistic. So test statistic X square value is 4.737, and the p-value, you get that in the calculator itself. So you have X square as 4.73 and p as 0.1920. Okay, 0.1920. So what can you make conclusion has? Since p-value is greater than alpha, you are going to say fail to reject H naught. That means home or visitor wins are independent of the sport. Okay, So this is how you have to do the hypothesis testing for the independence. Okay, so this will complete your chapter 11. If you have any questions, you can email me. I can help you.